MEM School of Engineering, Department of Mechatronics Engineering, online classes, subject analog devices and circuits, unit number 2. So that is unit number 2 is operation amplifier, characteristics and applications. Okay, last chapter we discussed the different characteristics of operation amplifier, then different configurations of operation amplifier, like that we discussed. So in this chapter, we go for the linear applications of operation amplifier. So generally, we can divide the application of operation amplifier into two parts. One is linear, another one is non-linear. So what is linear? If the output is connected, okay, if the output connected with the feedback, so feedback loop இருந்தாலே என்ன பண்ணலாம், நம்ம அதை வந்து linear application சொல்லலாம். Feedback loop இல்ல open loopல இருக்கு அப்படின்னா அதை வந்து non-linear சொல்லலாம். Okay, so then linear அப்படிங்கிறதுக்கான meaning, it will giving the output where the output varies with respect to the time period in the every interval. So the every interval என்ன பண்ணும், சேஞ்ச் ஆகிட்டே இருக்கும். தட் இஸ் 0.1 லேருந்து 0.2 மாறுதா வேரி ஆகும், 0.2 லேருந்து 0.3 மாறுதா வேரி ஆகும். ஓகே, பட் இந்த non-linear will not be changed, that is 0 or 1 தான் நமக்கு வந்து output கிடைக்கும். These are the different applications, linear and non-linear applications. So this is the op-amp used at the summing amplifier. This is the first application of the operation amplifier. Already we know that operation amplifier used for the arithmetic operation, addition, subtraction, multiplication and division. Okay, so first we are going to say about this summing amplifier or adder. Summing amplifier or adder. So depending on the input we are giving to the operation amplifier, we can divide it into the two, that is inverting adder and non-inverting adder. Inverting adder and non-inverting adder. So this is a model. That means we are giving input to the negative terminal. Okay, first input, second input, that is V1 and V2, then third input. So all the inputs are we are giving to the inverting terminal. So it is called inverting adder. So this is the equation for the inverting adder. That is V out is equal to minus IF into RF. So RF is IF is equal to I1 plus I2, I plus 3 and RF. Okay, by using the I value, I is equal to V by R. Using the values, we can get the output. That is V out is equal to minus V1 divided by R1 plus V2 divided by R2 plus V3 divided by R3 and whole multiplication with the RF. Okay. So by simplification, if you are using the resistance, that is RF, R1, R2 and R3, if all are same, the output V out is equal to minus of V1 plus V2 plus and V3 like will be like this. Okay. So this is the basic addition format. So here we are giving three inputs, 1, 2, 0.5, 1, 2 and 0.5. So that means the output will be 3.5. So that will be here. So here on question or sir, so inputs are in the positive cycle. So நமக்கு வந்துனா positive மாதிரி எனக்கு வந்து இருக்கு, but outputங்கிறது inverting-ஆ வந்திருக்கு because of inverting summer. So அப்ப நீங்க அந்த 3.5ங்கிறது என்ன இருக்கு, இதுக்கான அவுட் ஆஃப் ஃபேஸ்ல இருக்கு, 180 டிகிரி அவுட் ஆஃப் ஃபேஸ்ல வந்து இதுக்கான 180 டிகிரி டிஃபைன் பண்ணியிருப்பாங்க. ஓகே, so this is a simple example for the two input inverting summing amplifier, that is V1 and V2. So we are getting the output. So அதே மாதிரி different inputs. These are different examples for the use of different inputs using the add the different outputs using the basic models. So this is the non-inverting model. So in this model, we know that we are giving non-inverting terminal. So that is 1 volt and 1.5 volt. So the output will be 1.5. So you can see the output of 1.5 respect to the blue color line. Different amplifier output. So like that we have the different ideas. Okay. So next operational differentiator. Okay, we know that differentiator model. So if you differentiate the sine wave means output will be cos wave. So that is the mathematical operation. But in real time, we can take the differentiator of the sine waveform. If you're giving sine wave to the differentiator means output will be square wave. So sine means sine minus cos. So sine means normally differentiation of sine will be cos, but here we are using a non-inverting terminal, so output will be negative. That is minus will be happen in the output. Okay. So let's see the differentiator. An operational differentiator is an inverting amplifier which just uses a capacitor in series with the input voltage. A differentiating circuit are usually designed to respond to for triangular and rectangular input waveforms. For a sine wave input, the output of the differentiator is also a sine wave which is out of phase by 180 degree with respect to the input. So differentiator have frequency limitation while operating on sine wave inputs. The circuit attenuates all low frequency signal components and allows only high frequency components at the output. In the other words, the circuit behaves like a high pass filter. So this is the differentiator model. That means we are connecting the capacitor to the input terminal. Okay, it will be defined as the differentiator. So output V out is equal to minus R of C1 into dV divided by dt. That is rate of change of voltage with respect to the time period. Okay. So application of operational differentiator. So differentiating amplifiers are most commonly designed to operate at triangular and rectangular signals. Yeah, rectangular signals. That is, differentiators also find application as wave shaping circuits to detect high frequency component in the input signals, as well as the differentiator performs mathematical differentiation operation on the input signal with respect to the time. That is sine wave and cosine wave. If I are giving sine wave means you will get the minus sine wave. So square wave, if you are giving square wave means output will be a spike wave. So this is the input and output waveform of the differentiator. We have discovered a minus R of into C1 and a D V in by dt. Then frequency response of the practical differentiator. So the gain of the practical differentiator increases with the increase the frequency and the particular frequency. The gain becomes unity. So that is 0. The gain continues necessarily at the 0 or 20 dB. Okay, per decade. We'll transfer the input frequency, which is the frequency F2. Okay. So we'll see in the next class. Next class, we are going to see about the cylinder. Thank you.